Suasana dengan jitu penuh berisi guru ayu, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, hai semua. Okay, hari ni saya nak bagi serangkap pantun dululah. Okay, bersinar cahaya di senja dan petang, berlari-lari si anak dara, pemanis kalam, selamat datang, awal bismillah pembuka bicara. Bismillahirrahmanirrahim, Assalamualaikum dan salam sejahtera semua. Saya Cikgu Rosemawati binti Zaini yang bertugas di SMK Bandar Bintulu Sarawak daripada Akademi Youtuber bersiaran dari channel Cikgu Hasnitah kita. Sebelum kita mulakan kelas kita pada petang ini, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan umul kitab Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillah. Amin amin ya rabbal alamin. Alhamdulillah kita bersiaran sekali lagi dalam kelas tuition online Akademi Youtuber yang juga merupakan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Sebelum kita mulakan kelas, saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian dengan tontonan umum. Sila fokus pada isi pembelajaran yang akan disampaikan oleh Cikgu Hasnitah sebentar lagi. InsyaAllah semoga kelas kita ini akan dapat dimanfaatkan sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma daripada penelitian fizik menengah atas yang akan bersiaran pada hari Jumaat malam dan pada hari Ahad jam 2 petang. Baiklah, saya perkenalkan guru-guru yang ada bersama kita pada hari ini. Cikgu Hasnitah yang juga akan bertindak sebagai control host pada hari ini. Ingin saya perkenalkan presenter kita juga adalah Cikgu Hasnitah yang kini bertugas di SMK Bagan Jaya, Butterworth, Pulau Pinang. Okey, nanti beliau akan perkenalkan diri lebih detail lagi ya. Okey, juga diingatkan link penyertaan akan diberikan di penghujung kelas ini. Sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live. Hanya email e-didik Jawi MOE sahaja yang akan diterima. Tanpa melengahkan masa, mari kita ikuti kelas fizik pada hari ini yang akan disampaikan oleh Cikgu Hasnitah. Dengan segala hormatnya, dipersilakan. Okay, silakan Cikgu Hasnitah.
Okey, terima kasih sahabat moderator saya Cikgu Yani. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Apa khabar pelajar-pelajar sekalian, guru-guru? Okey, selamat datang dan terima kasih kerana bersama-sama dengan kita pada petang ini di mana juga anda berada. Minggu ini minggu cuti cuti umum Cikgu Yani sempena dibalik esok. Jadi marilah sama-sama kita luangkan masa lapang yang ada dengan kita menimba sedikit ilmu pada petang ini. InsyaAllah sama-sama kita manfaatkan ruang waktu dan peluang yang ada. Kami juga mengalu-alukan kedatangan guru-guru dan pelajar yang ada bersama dengan kita. So anda boleh kongsikanlah lagi link ini kepada anak-anak pelajar dan rakan-rakan yang lain. Mudah-mudahan lebih ramai lagi akan dapat manfaat daripada kelas kita pada petang ini insyaAllah. Dan sebelum pemula, cikgu ingin maklumkan anda boleh dapatkan link PDF kopi yang cikgu kongsikan pada ruangan chat. Ada cikgu pinkan di sana, anda bolehlah muat turun dan boleh juga dicetak keluar sebagai bahan rujukan. Dan cikgu harap anak-anak boleh respon kepada cikgu bila kita bincangkan beberapa contoh soalan berkaitan tajuk pada hari ini. So our topic for today is in chapter 6, Physics, Nuclear Physics, 6 6.1 is radioactive decay, reputan radioaktif. Tajuk ni senang ya Cikgu Yani, dan dia pun tak
Ya,
susah,
betul.
pendek saja 6.1 ini. Jadi marilah sama-sama kita lihat apa yang ada di dalam topik ini. Okay, sebelum itu Cikgu kongsikan, ini adalah jadual mingguan kita dan telah berlangsung pada Jumaat lepas kelas tingkatan 4 disampaikan oleh Cikgu Teacher Linda Nordin, asas gelombang, fundamentals of wave. Kelas ini disampaikan oleh Cikgu Linda. So kalau anda terlepas kelas ini, jangan risau, boleh tonton semula di portal IU www.Akademi Youtuber atau pergi saja ke channel Teacher Linda Nordin. Boleh juga ditonton dari sana. Okey, dan ini adalah rakan-rakan cikgu, sukarelawan IU, panitia fizik di Akademi Youtuber. Okay, barisan guru inilah yang banyak membantu cikgu menerbitkan video-video PDPC ataupun menjalankan kelas-kelas tuition secara percuma di IU. Jadi semoga anda dapatlah manfaatkan video-video yang telah dihasilkan oleh guru-guru berkenaan. Ada video dalam bahasa Melayu, ada juga video dalam bahasa Inggeris, especially untuk pelajar DLP. Okey, dan satu lagi ya Cikgu Yani, kita nak promote juga kita punya apps. Okay, apps Akademi Youtuber yang anda boleh download sebenarnya daripada Android anda. Apa yang ada dalam apps kita ni, mungkin Cikgu Yani nak promote sikit. Apa yang ada dalam apps IU ni, kenapa semua pelajar kena muat turun apps ini? Dekat sini dia himpunkan lebih daripada 20,000 video PDPC yang dihasilkan daripada sukarelawan IU daripada seluruh negara. Anda boleh tengok di sana video daripada prasekolah sehinggalah ke pra-universiti. Macam-macam subjek.
Kita ada semua subjek kan Cikgu Hasnitah, ada semua subjek.
Hampir ke semua subjek. Hampir ke semua subjek, dan kita sedang mengemas kini dari semasa ke semasa lah koleksi video yang ada. So dia punya apps pun tak berat, so tidaklah membebankan memori phone anda. Jadi anda boleh gunakanlah sebagai salah satu bahan untuk membantu anda semasa mengulang kaji. Nak tahu video AdMaths, dalam tu ada video AdMaths. Video matematik pun ada, sejarah, bahasa Melayu, bahasa Inggeris dan sebagainya. Okey. Jadi Cikgu Yani, jom kita mulakan kelas. Sebelum itu kita nak tengoklah siapa yang ada bersama kita petang ini. Anda boleh say hi, kita ada Sharing di sana. Yang lain pun jangan malu, jangan segan. Boleh perkenalkan diri. Sharing ni dia bagus ya, sentiasa ada. Alhamdulillah. Okey, Cikgu nak mulakan.
Cikgu Hasnitah, tadi sebelum memulakan apa-apa lagi, sebelum saya terlupa lah. Saya nak bagi tahu kod rahsia kita untuk yang dua. Yang pertama, ni siapa yang ada kat ni? Ada A3. Saya umumkan yang dua yang terawal dulu. Eng ada di sini. A3 ya, Eng simpan ya. Okey, Cikgu Hasnitah.
Okey, terima kasih Cikgu Yani. So kod kita yang pertama, kod yang pertama A3. Anda catatlah di mana-mana. Okey, kali lagi. Cikgu nak mulakan dengan salah satu short clip dekat sini. Anda boleh teka tak gambar apa yang cikgu tunjuk sekarang ni? Can you guess, students, what is the short animation I show to you now on the screen? Rasa-rasanya tahu tak benda apa ni? Pernah tengok tak kalau Google dekat internet tu? Nampak rupa-rupanya macam apa tu? Ada kaitan dengan tajuk yang kita nak kongsi hari ini. Okay. Anyone, can you guess what do we have here? Hi, Ting, Kiat Hong. Good afternoon.
Ya, kita ada adik
Thank
Jing
you for joining us. Okay, Kiat Hong, can you guess what is this short animation teacher share to you here? Boleh teka tak apa ini? Ini adalah this is tokamak fusion reactor. Pernah dengar? Whoever heard tokamak fusion reactor, can you say yes? Or this is the first time you heard about tokamak fusion reactor. So what is tokamak fusion reactor, students? Since today we are learning radioactive decay, so this fusion reactor is something very close to it. So the name tokamak, nama dia tu tokamak. Kalau dengar macam nama-nama Rusia kan, tokamak ini comes from a Russian acronym for toroidal chamber with magnetic core. Toroidal ini maksudnya dia shape itu seperti donat. It has a shape radioactive. Yes, it is a radioactive reactor, nuclear reactor. Okay, so actually this tokamak is an experimental machine. Dia experimental machine designed for what? Is to harness energy of fusion. Kita nak generate tenaga elektrik digunakan tokamak ini. And inside this tokamak, what do we have inside this tokamak? The energy is produced through fusion, nuclear fusion, which we will learn in 6.2 later on. And this fusion produce atom absorb a heat in the wall of the vessel, and then finally, just like another conventional power plant, seperti juga penjana kuasa yang lain, a fusion power plant will use heat to produce steam and to generate the turbine and generator. So kegunaan dia adalah untuk menjana tenaga nuklear daripada proses nuklear yang berlaku di dalam, dan tenaga yang dijana itu adalah sangat-sangat besarlah, sangat-sangat tinggi. Kalau anda boleh baca beberapa fakta di sana, a tokamak can sustain plasma current, with electric current equal to the most powerful bolt of lightning known as mega ampere level. So sangat tinggi tenaga yang dihasilkan. Okay. And for your information student, in year 1997, the JET tokamak in England has managed to generate a fusion power output at 16 megawatts. So mereka telah berjaya menjana tenaga output yang sangat tinggi, 16 megawatt. Dia ada banyak sebenarnya tokamak ini, ada di beberapa negara, di USA, ada di England, Rusia dan sebagainya. And kalau anda lihat struktur dia, if you look at the central solenoid used in the tokamak will be the largest superconducting magnet ever built. So anda telah belajar sebelum ini in chapter 3, you've learned in chapter 3 electromagnetism. So here they apply the magnetic field concept in generating very huge nuclear power here to supply electrical energy to the consumer. Okay, yeah, radioactive, something to do with the radioactive. The radioactive process occur inside the reaction chamber. Okay, so anda boleh Google, you can Google for more information on tokamak fusion reactor. Okay, Cikgu Yani sebagai pengenalan saja. Okay, sekarang mari kita lihat. Okay, let us check our first learning standard student in 6.1. Altogether, we have 4 learning standard which you need to master very well. Okay, equation involving alpha decay. Before that we begin with the alpha, beta and gamma decay, let us first ask ourselves, what is radioactive decay? Okay, apa itu reputan radioaktif? Okay, Kiat Hong, can you try to answer? Chia Ying or anyone else with us this afternoon? What is radioactive decay? For those who have learned in school, I believe you will know what is radioactive decay. And this is not the first time you met this. So saya percaya ini bukanlah kali pertama anda mendengar reputan radioaktif. Because sekarang di silibus fizik banyak yang telah diajar di peringkat lower form. Betul lah Cikgu Yani, asasnya banyak mereka dah belajar semasa tingkatan 1, 2 dan 3.
Ya, betul.
Okay, students. Right. Okay, what is radioactive decay? Okay, it is referred to a process. Okay, radioactive decay is a process where an unstable nucleus become more stable by emitting radioactive radiation. So dia adalah satu proses di mana nukleus yang tidak stabil, iaitu bahan radioaktif yang tidak stabil, menjadi stabil dengan memancarkan sinaran radioaktif. Okay, so what happened? And this process occur randomly and spontaneously. Proses ini dia tidak bergantung kepada mana-mana faktor. Ada saja nukleus tak stabil, okay, dia akan mereput dengan sendiri. Okay, it is a random process and spontaneous, thus not affected by temperature, pressure, and any other physical factor. And students, when the unstable nucleus decay, they will emit and radioactive radiation, namely alpha, beta, and gamma. And in some cases, they emit more than one type of radiation. Okay, they can emit alpha and beta at the same time. The process can emit alpha, beta, gamma at the same time. Later, we will see a few examples of a radioactive decay process involving certain radioactive nuclei. Okay, so yang pertama kena tahu maksud dia. Apakah reputan radioaktif? Proses di mana Nukleus yang tidak stabil mereput menjadi nukleus yang lebih stabil dengan memancarkan sinar radioaktif. Okay. Process in which unstable nucleus become more stable by emitting radioactive radiation. Okay, so before we check on alpha, beta and gamma radiation, we check first on the characteristic for all these particle, alpha, beta and gamma. So alpha particle exists as a helium nucleus. Dia sebenarnya adalah nucleus helium, helium-2, okay. While for beta, it is a fast moving electron. Okay, beta is a fast moving electron. While for gamma, if you remember, you learned in form 5, you learned in form 4 last year, chapter 5, 5.7, electromagnetic wave. So gamma is a type of electromagnetic wave which a very high frequency. Okay, and this is the mass for alpha, beta and gamma. So alpha has a greater mass if you compare these three. And talking about their charges, helium has positive charges. Okay, electron is a negatively charged. While how about gamma, students? Gamma is a neutral. It doesn't have any charge. And this is how they move. Alpha, since the mass is very big, so it moves in a low speed. Dia berat, so dia punya pergerakan pun perlahan. Okay. While for beta, which is lighter, so it moves at the 90% of the speed of light. Okay, very fast. Meanwhile, the fastest is gamma. Gamma move at the speed of light. Who remember what is the value for speed of light? Siapa ingat berapakah kelajuan cahaya? Boleh tulis dekat live chat sana. Okay. And then what's next? This is the ionizing power for each. Alpha has a very high ionizing power, medium for beta, and very low for gamma. And talking about the penetrating power, it is the opposite one. Alpha has a very low penetrating power, beta is medium, and gamma has a very high penetrating power. Okay, that's why we have to store all this radioactive material in a very thick lead container. Sebab dia sangat bahaya kita simpan bahan radioaktif ini di mana Cikgu Yani kadang dia suka tanya dalam soalan, kita simpan dalam bekas yang diperbuat daripada plumbum yang tebal. Okay, dan alpha, since the penetrating power is very low, yes, very good, Kiat Hong. Okay, 3 times 10 power of 8 meter per second, very good. So alpha can be stopped by a piece of paper because it has a very low penetrating power. So it cannot pass through a piece of paper, can be blocked by a piece of paper. While for beta, we can stop by placing aluminium in front, okay, a few millimeter aluminium. While for gamma, it only can be stopped by thick lead, okay, plumbum yang tebal, a few millimeter lead. Okay, and this is to show their deflection in electric field and magnetic field for each. For alpha, yes, it shows deflection in electric and magnetic field. Since alpha is positive charges, so in electric field it will deflect to the negative charge. Okay, meanwhile for beta, it also show deflection in both field. And beta, since it is negatively charged, so in electric field it will be deflect to the positive terminal. And for gamma, what do you think? Any deflection in electric and magnetic field? Yes or no, student, for gamma? Okay, gamma is a neutral, no charge, so it doesn't show any deflection. So it will continue travel in a straight line in between electric and magnetic field. Okay, and talking about magnetic field, how to know the deflection for alpha and beta? You can apply Fleming's left hand rule, okay, to determine the direction. Okay, we know where is the direction of current flow, where is the polarity of the magnet. So you can determine where is the direction of the deflection by checking on the direction shown by your thumb. Nah, ingat ya, Fleming's left hand rule, FBI. The thumb shows force, index finger shows direction of magnetic field, always pointing to the south. And then your middle finger pointing to the direction of flow of current. Okay, that is with the characteristic of alpha, beta, and gamma. Okay, now we go one by one to the decaying process. Alpha decay, beta decay, and gamma decay. Okay, first student, for alpha decay. Okay, this is example of alpha decay. Okay, so this is an unstable nucleus. X, ZA is an unstable nucleus, so it will undergo radioactive decay in order to become a more stable nucleus, a new nucleus Y. Okay, so when it release alpha particle, so we understand that above is a nuclear number. So the nuclear number will be reduced by 4. Okay, while for the proton number will be reduced by 2. So we understand this process emit helium alpha particle. Okay, in the example, parent nucleus unstable, decay become a new daughter nucleus which is more stable, emit alpha particle. Okay, and then this is the example of alpha decay. We have polonium there. Okay, polonium 210 is unstable. Decay become a new daughter cell. Okay, a new daughter nuclei. Lead 206, plumbum 206. So this process release alpha, which is helium. So if you add this 206 plus 4, the nuclear number will give you back 210. If you plus the atomic number, the proton number for lead and helium, 82 plus 2, so we'll give you back the atomic number for proton number for polonium, which is 84. Okay, so after decay, daughter nucleus has number, proton number Z minus 2, and the nuclear number reduced by 4. Okay, that is alpha decay. Very simple, the process. Okay, now we check for beta decay. Again, student, X, unstable radioactive nucleus. So what will happen to it? It will undergo spontaneous and random radioactive decay, became a new daughter nuclei Y. So since it released beta particle, which is electron, so there is no changes in the nuclear number. Okay, remain as A, but there is a changes in the proton number, increased by 1. Okay, since beta has negative 1. Okay, example of radioactive decay of parent nucleus involving one emission of beta particle. And this is the example. Ini contoh dia. Okay, we have sodium there, natrium, sodium 24, unstable. So will be decay, became a new daughter nucleus, magnesium 24. And this process release 1 electron, beta. Okay, so when you plus 24 plus 0 will give you back the parent nuclear number 24. And when you plus this magnesium proton number 12 plus proton number for electrons, so will give you back 11. Okay, the parent proton number. Very simple. As how you balance an equation in chemistry, kan mereka biasanya menyeimbangkan persamaan kan Cikgu Yani dalam subjek kimia. So for beta decay, we understand after the decay where electron is emitted, so the proton number for daughter nucleus become Z plus 1, but no changes in the nuclear number. Okay, we go to the third type of decay, gamma decay, student. Again and again, X, unstable. Okay, unstable. It has a very high energy, now decay, but this one for gamma, it became a same nucleus. But for this one, the new one has a least number of energy. Yang ini dia tak stabil, tenaga dia sangat tinggi. Bila dia mereput, dia menjadi nukleus yang sama, tetapi bezanya sini tenaga dia dah lower down. So dia sudah stabil sikit sebab tenaga yang berlebihan itu telah dikeluarkan. Okay, the excessive energy has been removed out, so the nuclear becomes stable. Yang inilah. Okay. So this is the example of gamma decay. This one is cobalt 60. Okay, decay, cobalt 60 with very high energy. Decay became cobalt 60 with a lower energy. Okay, releasing 1 gamma ray. Okay, so after gamma decay, no changes in the proton number and nuclear number. The nucleus is less energetic after gamma decay. So yang ini dia punya produk sama, only the changes is in the amount of energy will be lower. Okay, so are you clear with alpha, beta and gamma decay, students? Boleh faham ini, senang saja kan? Okay, so kita tengok yang seterusnya. Okay, this is another example of alpha, beta and gamma decay. Okay, so we have uranium-238. This is a radioactive material. So it is unstable, so it will undergo radioactive decay to become a more stable nuclei thorium 234. So this process emit 1 helium atom. So we understand here this process release alpha radiation. Okay, and this is example of beta decay involving thorium 234. Okay, sometimes student, kadang-kadang Kak Cikgu Yani yang terhasil di sini ni selepas perebutan yang pertama, dia tak begitu stabil lagi. It is not very stable yet. So later it will undergo another decay process. Macam ni tadi kan. Tadi dia keluar thorium dan thorium ni dia tak apa stable lagi, not very stable yet. So it will undergo a new radioactive decay. Now thorium 234 emit beta particle became palladium 234. So sometimes it happen in a series of radioactive decay. Bukan sekali saja. Sometimes more than 1, more than 10 it can be. Okay, and this is example of gamma decay of cobalt 60. So this process also produce cobalt 60 with less energy, which is more stable than the previous one, and this process emit gamma ray. Okay, so kalau anda lihat nuclear number does not change for gamma ray, atomic number, proton number also does not change for gamma decay. For alpha decay, you can check the nuclear number reduced by 4. Okay, 238 reduced to 234, so we understand release 1 helium. For beta, there is no changes in the nuclear number, but the proton number increased by 1, so we understand beta is released in this process. Okay, itu saja yang pertama. Okay, then we check. During a radioactive decay, student, some nuclei can emit more than one radiation. So it doesn't mean they only emit alpha, they only emit beta, they only emit gamma. Sometimes they emit all three. Kadang-kadang semua pun dia akan keluarkan. Okay, for example, during the decay or disintegrate. Disintegration is another name we give for radioactive decay. Okay, uranium 234. The nucleus emit alpha and alpha particle and gamma ray at the same time. So we check from this. This is uranium 234. It is unstable, so undergo radioactive decay, produce a new daughter nuclei called thorium 230, and it release 1 helium. Helium is alpha plus 1 gamma. Okay, so when we simplify this equation, this is how it becomes. Uranium 234 decay into thorium 230, releasing 1 alpha particle and gamma ray. Okay, so then let us take a look at this next example. Okay, students, okay, so let us check your understanding. If you can follow me in this first learning standard, itu saja Cikgu Yani, standard pembelajaran yang pertama, to understand alpha decay, beta decay and gamma decay. Okay student, can you respond with me? The first question on checkpoint 6.1.1. When a nuclide undergoes alpha decay, so it stays here alpha decay. So what happened to its nucleus number? Apa berlaku pada nombor nukleon apabila satu nuclide mengalami perebutan alpha? So you must know what is the structure for alpha. Okay, so this is the clue. Okay, we have X, unstable nuclide, undergo radioactive decay, become a new nuclide Y, which is more stable, emitting 1 alpha particle. So we understand the nuclear number is on top. Jangan terbalik Nuclear number is on top, A reduced by 4. Proton number below reduced by 2. So which one is the answer? Is it increased by 4, decreased by 4, increased by 2, decreased by 2? Apa berlaku pada nombor nukleon di atas? Bertambah 4 ke, berkurang 4 ke, bertambah 2 ke, berkurang 2? Mana satu jawapan dia? So yang ini salah lah, anda boleh lihat. Ini dia punya proton number. A, Z. So kita nak tengok nuclear number, ini nombor yang di atas. Nombor yang di sini, nuclear number. So, reduce by 4. Anda boleh lihat. Yes, very good. Kiat Hong, answer is B, decreases by 4. Okay, try the next question, student. Second question. Okay, now we have thorium. Sekarang kita ada thorium 232, unstable. Okay, so it decays to become more stable nuclear plumbum, Oleh 208. So the question is, how many alpha and how many beta particle are emitted during the process. Berapa banyak alpha dan beta yang dikeluarkan semasa perebutan tersebut. So what is the first thing you must do in tackling this question? So first you can write the equation, okay, the formula. So we have thorium 232, decay become lead-208. So can you see the changes on the nuclear number from 232 reduced to 208? Proton number from 90 reduced to 82. So what can you do? You can check first, okay, the nuclear number on top. The changes is 24. Okay, changes is 24, reduce the 24. And then for the proton number below, Z, okay, the changes 90 minus 82, so produce 8, which means whatever it produced here, the total nuclear number will be 24 and the total proton number will be 8. Which means you can check, you must check one by one for this given answer. Is it A, 3 alpha 1 beta, or B, 6 alpha 4 beta, or C, 3 alpha 2 beta, or D, 6 alpha 1 beta? So how to do this? So you kena check satu-satu. You have to check. Okay, 3 alpha 1 beta. Okay, so we check. This is the nuclear number. Okay, 3. This is the nuclear number for alpha, which is 4. And for beta, the nuclear number is 0. So the total here is 12, okay, for the nuclear number. And for the proton number for alpha is 2. So we have 3 alpha there. So that's why we multiply by 3. And for beta, the proton number is -1. And the amount is 1. So the total is 5. So A correct or not? Supposed to be 24 for A and 8 for Z. So A is wrong. So you can check. Check for B, for C, and for D. Okay, so you will find the answer will be, if you check from here, the answer will be B. Okay, 6 alpha plus 4 beta. Very good, Kiat Hong. Okay, 6 alpha 4 beta, so will produce 24 nuclear number in total, and for the proton number will be produced 8 in total. And don't forget the negative sign for proton for beta. Okay, senang saja kan? Very simple. Okay, we check on the third question. Okay, again, this is the equation showing the decay of thorium 234. So this is thorium 234, an unstable radioactive nuclide. So what will happen to this thorium? It will undergo decay, became a more stable nuclide by releasing radioactive radiation. So here it released alpha, helium, and at the same time it released beta, okay, electron. So you have to find two unknowns there. We have two unknowns there. If I magnify this for you, you have to find X. X is here, okay, the proton number for this radium, okay, the new element formed from the decay process. And then Y, what is the number? The number of helium produced, the number of alpha produced. So we have two unknown there. So which one you can find first, student? This is balancing an equation as how you normally did in chemistry. So yang mana boleh cari dulu? Boleh cari X dulu ke? Boleh cari Y dahulu? How to find X and Y? Okay, you can check and try this question. What is the value for X and Y? So the clue is you can find Y first. Anda boleh, so you have to count. You have to count what is the total nuclear number at this site and what is the total of proton number on the product. Itu clue dia. Okay. So to find the total number of the nucleon and the total number of the proton, okay, you can find the nuclear number first, okay, which is involving Y. Kalau you cari yang bawah dulu, nanti yang bawah dia ada dua unknown, X and Y. So we cannot solve. So we find the nuclear number first because only involve one unknown there, which is Y. So this is the reactant on the left for thorium 234. And on the right side of this equation, we have 226 for radium. And then for helium, we have 4Y because Y is unknown, right? 4Y. And then for electron beta, we have 2 electron. So this is the nuclear number. So you solve by simple mathematics only. So this will give you Y of 2. So we know Y is 2. So where is Y2? So the answer is either B or C. And then we check for X. So X, you can find the proton number on this side at below. Okay, so here the total proton number for thorium is 90, and on the right side you have to plus all. Okay, this is for radium, X. So for alpha it is 2Y, okay, 2Y, and for beta it is 2 multiply -1. So then you can substitute, since Y, we know Y is 2, so X give you 88. Yeah, very good, get home again. So the answer is C. X 88 and Y is 2. Senang saja kan? Very simple, right? Okay, that's all to do with the first learning standard. To understand alpha radiation, alpha decay, beta decay, and gamma decay. Okay, now kita tengok yang kedua, Cikgu Yani. The second learning standard is to explain half-life through example. Apa itu separuh hayat? Okay, students, half-life. Okay, so to understand half-life, this is the curve for half-life. Okay, the blue color is the parent, okay, the parent nuclide, and the red color is the daughter nuclide. So when half-life occur, the number of parent nuclei will be decreases. Meanwhile, at the same time, the number or the amount of the daughter nuclei will be increases. Okay, so blue is our initial nuclide. Okay, warna biru itu yang asal, yang unstable. So they will undergo they will experience half-lives and become a new nucleus, which is the red in color. So what is half-life, student? Half-life is the time taken for a radioactive nuclei to decay to half of its initial mass or initial content or initial activity. Apa itu separuh hayat? Masa yang diambil oleh sesuatu nukleus radioaktif untuk mereput menjadi separuh daripada jumlah asalnya, separuh daripada jisim asal, separuh daripada aktiviti asal. So maksud dia, asalnya dia ada 100% lah, 100% the content. So after one half-life, so what happened? It will split into two. So 50% remain, 50% decay. Okay, then another half-life, this 50% will be divide back into two. So 25% left, 25% decay. And this process continues. Okay, dia berterusan. So apa berlaku semasa proses ini? Apabila suatu sampel mereput, bilangan nukleus radioaktif yang belum mereput akan berkurang dengan masa, manakala bilangan nukleus anak semakin bertambah. So when a sample of radioactive material decay, the number of parent nuclei which is unstable will be decreases. Okay, with the time, while the number of daughter nuclei will be increases. So produk dia semakin lama semakin banyak lah. Okay, so kita tengok then after one half-life, the number of nuclei that are not decay will be half of its initial value. Selepas satu separuh hayat, bilangan nukleus yang belum mereput akan menjadi separuh daripada nilai asal. So kita tengok contoh di sini. Okay, this is a series of complete decay series for uranium 238 to lead 206 with their respective half-life. Okay, kita mula daripada sini. Ini boleh dapat daripada buku teks. Contoh, cikgu ambil contoh saja. Okay, this is uranium 238, unstable. So will undergo radioactive decay. Decay become thorium. Okay, and this process took about 4.5 times 10 power of 9 years. So this is the half-life. Okay, it means initially we have 100% uranium here. So after this period, it become less. 50% decay, 50% remain. So decay become a new one and release alpha particle. And then what happened to this thorium? Ini belum stabil lagi, Cikgu Yani. So dia akan decay lagi. And the time took for thorium to decay into palladium is 24.1 days. Ini lebih singkat. Mean after 24.1 days, half of this thorium will be decay, another half remain. Dan kalau kita tengok seterusnya samalah. This is palladium. Need 1.8 minute to become half of this initial content, become a new daughter nuclear uranium-234. Sampai di bawah sini. So this process, decaying process continuously occur until finally it reach the stable nuclear daughter cell, which is lead 2O6. So bila dia sudah betul-betul stabil, dia akan berhentilah. Dia berhenti sendiri. It will stop itself to decay. So it will remain, it will exist as lead 2O6. So kalau anda perhatikan, semua unsur ini dia ada half-life yang berbeza. Each radioactive nuclei has a different half-life for each. Ada yang sangat lama, ada juga yang sangat sekejap. Okay, ini in years, this one in days, for this one in minutes, we also have in seconds for this one. Polonium to lead 2O10 only require 1.64 times 10 negative 4 second, means the rate of decay is very high. So dia mereput dengan sangat cepat. Okay, very fast. This one very slow. Okay, the rate of decay is very low. Okay, then students, next. Okay, so from this understanding, actually we can do a few things. For example, the geologist. Okay, the geology. Anda tahu kan ahli geologi, bila mereka buat satu carian, cari gali, and they found a fossil or a rock, for example, they can estimate what is the age of that rock, what is the age of that fossil by calculating the ratio. Okay, the ratio of the daughter nuclei to the ratio of the parent nuclei. Dia boleh hitung nisbah. Contoh kita ada plumbum. Plumbum 2O6 mereput kepada uranium. So ini yang asal, ini yang baru. So dia akan ukuran nisbah, okay, uranium kepada plumbum. Kalau lagi banyak plumbum di dalam tu, itu anda lihat plumbum ini is the new daughter cell, maknanya batu itu lebih berusia lah. Maknanya telah banyak, okay, most of the uranium has been decayed into plumbum or red. Okay, this one by ratio. Contohnya di sini, we start with all uranium, okay, before decay process. So after decay, after one half life, okay, the red dot ini become half. So another half become plumbum. Okay, then after two half life, okay, so the red one decay more into half. Okay, so the blue dot increases, the red dot decreases. So after three half life, only two red dot remain, mean only two uranium atom remain. The rest have been decayed into the daughter nuclear, which is plumbum. So kita tengok lagi banyak yang nuclear itu di sel anak itu, maknanya lebih lama lah, lebih panjang lah usia sesuatu batuan itu. Okay. Another method other than estimating the age by ratio, this is the second method the geologists are using, carbon dating. Kita pentarikan carbon. Okay, how? By calculating the percentage of carbon-14 inside a fossil or inside the rock. Okay, for your information student, untuk maklumat anda, semasa kita hidup, sebenarnya kita absorb C14 ini daripada alam sekitar. Okay, kita absorb C14. Carbon 14 ini dia adalah radioisotop daripada carbon 12 dan carbon 13 radioisotop. Carbon ni dia ada banyak isotop. Carbon 12, carbon 13, carbon 14. So carbon 14 itu is the radioactive one. Okay, dan kita ada dalam badan kita sebenarnya sebab kita dapat daripada apa yang kita makan. Okay, we absorb C14 from the surrounding, from what we eat. Okay, nanti kita tengok, cikgu bagi tunjuk contoh. Okay, for example, this animal. Okay, when this animal dead, apabila haiwan ini mati, what will happen? The first day it dead, okay, so hari pertama dia mati, the percent of carbon-14 in its body is 100%. Okay, and as time goes by, okay, decay process occur in the carbon-14. So after one half life, which is 5,730 years later, 15% remain. Okay, 15% carbon-14 remain in this skull. Contohlah you gali-gali, you jumpa satu tengkorak. Okay, and then after second half life, so 25 of the C14 left. So So this is the age of that fossil, 11 years, 460 years, and so on. Okay, after third half-life, 12.5% of C14 remain in this skull. So it can tells you the age of this skull now is 7,190 years. Ini cara kita anggarkan umur fosil. The way we estimate the age of a fossil. Contohlah, you gali-gali jumpa satu tengkorak dinosaur, jumpa satu tulang mammoth. So how is the process conducted? They will bring the sample to the lab. Dia bawa lah sampel itu pergi lab. They clean it, bersihkan and apply some chemical on it. Dia akan campur dengan bahan kimia yang tertentu, undergo a certain chemical process in the lab. And finally, they will put it in the radioactive counter. Dia masuk dalam satu alat yang boleh kesan. What is the percentage? So from there, they can estimate the year of the rock and the age of the rock and the age of the fossil. So very interesting field to study, geologist. Ada tak yang minat nak jadi geologist di sana? Good evening. T-Vash ni esok nak sambut Deepavali ni Cikgu Yani tapi masih sempat lagi join kelas kita pada petang ini. Very good T-Vash. Okay. Kita ada juga Cikgu Rohana di sana. Waalaikumsalam Cikgu Rohana. Terima kasih join dan support kelas kita pada petang ini. Sahabat saya dari Terengganu, Cikgu Rohana. Okay students, so this one Cikgu bagi tahu tadi, use carbon dating technique by calculating the percentage of carbon 14 remain in the sample. Ini yang Cikgu bagi tahu tadi, macam mana carbon 14 ini boleh berada dalam badan kita. How is this carbon 14, radioactive carbon can end up in our body. So it come from the cosmic radiation from the sun. Okay, and the sun will be absorbed by the green plant during photosynthesis, including carbon 14. So then we eat the plant as our sources of food. Kita makan sayuran, kita makan buah-buahan sebagai sumber makanan. So dengan tidak langsung carbon 14 itu masuklah dalam badan kita. So this is the way our body absorb carbon 14 from the plant. Okay. And after we die, what happened as our body decompose? So the carbon 14 also decompose or decay according to its half-life. Okay, ini caranya. Okay, so dalam badan kita memang ada readily carbon 14. Okay, so boleh nampak lah, you boleh Google juga dalam internet. Carbon 14, how does living thing absorb carbon 14? Okay, you can read more explanation from that. So Cikgu Yani rasanya kita take 5 sebentar boleh? Sebelum kita sambung dengan standard pembelajaran yang seterusnya.
Okey, sebelum kita berehat sekejap, Cikgu nak bagi dululah kod yang seterusnya ialah 79. Bagi yang tertinggal tadi kita bagi A3 A3 and then 79. Okay? Alright. Okay, take 5. Okay.
Tuisyen online percuma. Tuisyen online percuma. Layari www.Akademi Youtuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi Youtuber.
Okey, Cikgu Yani tak buka mic.
Okey, kita teruskan bersama Cikgu Hasnitah. Ya, silakan Cikgu.
Okey, terima kasih. Okey students, pelajar-pelajar, mari kita sambung dengan standard pembelajaran yang seterusnya. Okey, in the first two learning standard we have learned about, the first one is what is radioactive decay. So again, it is a spontaneous disintegration of unstable nuclei to become more stable nuclei by emitting radioactive radiation. So Apa itu reputan radioaktif? Dia adalah proses pereputan yang berlaku secara spontan ke atas nukleus yang tidak stabil untuk menjadi nukleus yang lebih stabil dengan mengeluarkan sinaran radioaktif. Okay. And second, we have learned about half-life. Half-life is a time required for the radioactive material to decay into half of its initial mass. Separuh hayat adalah masa yang diperlukan oleh bahan radioaktif untuk mereput menjadi separuh daripada aktiviti ataupun jisim asal. Okay, senang saja. Okay, then kita nak masuk kepada yang ketiga. This is to determine half-life of radioactive sources from a decay curve. Okay, this part involve a few calculations. So anda boleh bersedia dengan calculator. Kita nak tengok graf lengkung untuk half-life. Okay, before that, this is the decay series I showed to you before yang sangat panjang itu daripada uranium-238 sampailah akhirnya dia menjadi plumbum-206. Okay. So the concept of half-life can also be expressed in the form of decay series as follows. So how to understand this decay series? So this is the first sample, okay, and not the first content, 100%. So after the first half-life, it has been reduced by half. Okay, the sample content reduced by half. Another half have been decayed into a new daughter cell. And then after the second half-life, okay, reduced into another half. After the third half-life, reduced into another half and onwards. Okay, so kita boleh come out dengan satu formula ini, where n, this is the number of cell left. Okay, the number of sample left equal to, this is the half-life, and ini number of half-life, and n naught ini is the initial number, the initial content. So anda boleh selesaikan. Katalah dia tanya berapakah sampel yang tinggal, how much sample left after a certain period of time given. So anda boleh hitung menggunakan formula ini. Okay, nanti kita check soalan how to apply this formula. Okay, then this is the example, students. Okay, this is the initial condition, okay, and not initial sample, the initial content. Okay, ini the number of decay radioactive nuclei, okay, 0. Okay, then awalnya lah dia tak mereput lagi, okay, and this is the radioactive nuclei that has not decayed, the orange color, and for white color shows the decay radioactive. So asalnya dia 100% lah. The process is not started yet. The decay process is not started. Belum lagi bermula. So after the first half-life, apa berlaku? So this one become half. Okay, the number of radioactive nucleic acid become half. Okay, so which mean this one become half and not. So this is what happened to the content. Okay, orange is not decay yet. White ini already decay, become a new nuclei. Okay, then after the second half-life, okay, now this half reduced by another half, so become quarter. Okay, and this one is the sample that have been decay. So 1/4 masih tinggal, 3/4 sudah mereput. Okay, and this is the structure. So ini saja yang tinggal. Okay, yang ini putih semua sudah mereput. All the white color has been decay. After the third half-life, so reduced by half, become now 1/8. Okay, and ini remain, ini yang sudah decay 7/8. Okay, then dia menjadi lebih sikit lah, portion dia become less and less. Ini another half. So from here 16 now become 8. Okay, yang putih itu semua sudah decay. The fourth half-life, the same thing, so only 4 remain undecay. The remaining yang left semua sudah decay, already decay. Okay, and when it reach the fifth half-life, so what happened? This is what left. Okay, 2 parts not decay yet. Yang lain semua sudah decay. All the rest have been decay into a new nuclei. So this is how we understand the initial condition and the final condition when a process undergo decay process involving half-life. Okay. Then students, okay, this is the decay curve. Ini graf lengkung reputan radioaktif. Kita tengok sini, contohnya di atas ni kita ada cobalt 60. Okay, cobalt 60. So this is the initial content, 100%. So after the first half-life, so 100%, how much remain? 50, half. Okay, 50. So what is the number ini? First half-life. Okay, first half-life. And for cobalt-60, the half-life is 5.27 years. Okay, which means initially 100%, after 5.27 years, 50% have been decay, 50% remain. Tadi awalnya 10 gram. Sekarang after 5.27 years, only 5 gram remain, which means another 5 has been decay. And then dia continuous, their time goes by as the time goes by. So after the second half-life, mean after the next 5.27 years. So now from 50 reduced into half become 25. Mean now 2.5 gram left, 2.5 gram decay. Okay, then for the third half-life, okay, now from 25 divide to 12.5% left. Okay, about 1.25 gram. And fourth half-life, this is the remaining part and then continuously. Okay, ini macam mana kita faham graf lengkungan radioaktif. Okay, then this is another example down here. Show before the process started. This is after the first half-life reduced into half. So this is the second half-life reduced into another half, and this is the third half-life reduced into another half. So setiap kali dia reduce separuh. Okay, and the third curve ini shows that Cikgu Yani yang ini dia menunjukkan ada dua jenis. Okay, we have two sample, the green curve and the red curve. Okay, it shows dia for the red curve, the gradient is higher, right? So apa maksud dia? For this material, it has a higher decay rate. Maksud dia punya half-life itu lebih singkat. Maknanya dia mereput dengan lebih cepat. The sample decay in a shorter time compared to the green color. For this material, it has a lower decay rate. Mungkin dia perlukan masa 10 tahun baru dia mereput menjadi separuh. Ini dia perlukan 5 tahun saja untuk mereput menjadi separuh daripada kandungan asal. Okay. Okay, then kita tengoklah contoh. Okay, contoh soalan. Okay, to understand curve graph for half-life. Okay, cuba jawab soalan ini. Okay, we have question 4 here. Which statement is correct? You are given with a graph of radioactive against time for two radioisotope X and Y. So ini lebih kurang sama macam apa yang cikgu tunjuk sebelum ini. We have two sample, X and Y. Okay, X and Y. So this is a decay curve for X and Y. So which statement is correct, student? A, X is less stable than Y. Betul ke X less stable? B, the decay rate for X is higher than Y. C, X and Y are suitable to be used in industries. And D, half-life for X is longer than half-life of Y. Yang mana jawapan dia? Okay, cuba respond. Try to respond to question 4. Which one is correct? You are given a graph showing radioactivity of X and Y. So cikgu tunjuklah clue dia. Ini graf yang cikgu tunjuk tadi. Okay, this is the graph related to this question. So you can compare this curve. So the red curve can be represent Y. Okay, the green curve represent X. So what can you say? Kiat Hong say A, X is less stable than Y. Okay, how about the rest? What do you say? Kiat Hong kata X kurang stabil daripada Y. Betul ke X kurang stabil daripada Y? Siapa yang akan lebih stabil dahulu? Yang lebih cepat mereput ke yang lebih lambat mereput akan lebih stabil? Cuba anda baca betul-betul soalan dia. Okay. So is it A, B, C or D? So actually the answer is D, Kiat Hong. Okay, the answer is D. The half-life of X is longer than the half-life of Y. So X ini it has a lower decay rate. Mean it took longer time to decay compared to X, compared to Y. Y ini has a higher decay rate. So it decay in a shorter time compared to Y. So Y ini dia perlukan masa yang lebih pendek untuk mereput. Sebab dia punya kadar reputan itu tinggi. Sebab dia punya graf itu dia lebih curam. Ya, correct, Divesh. Okay, so answer is D. Ya, the lower the rate, the more stable. Okay. Number 5, student, checkpoint 6.1.3, question number 5. Again, you are given a graph of activity against time for radioactive element. Okay, they give you the initial activity is 400 count per minute. Ini bilangan asal dia lah 400. And here the time 2 minutes, 4 minutes and 6 minutes. Okay, so the question is, after 6 minutes, how many half-life has the element gone through? Selepas 6 minit, berapakah separuh hayat yang telah dilalui oleh elemen tersebut? So you can check from the graph. Macam mana tengok? Senang saja. So this is the first content, 400. Okay, dia mula dengan 400. So after the first half-life, berapa? After the first half-life, it become 200. 50%, right? Ini. So this one is the first half-life after 2 minutes. Okay, then after 100. Okay, so reduce to 100. So ini the first half-life. Okay, the first half-life. This is the second half-life. Ini the second. And then after 100, decay into 50. Sini dia tunjuk sampai 50 kan. I mean, how many half-life involved there? 3 half-life. Okay, so 3 half-life. So the half-life is 2. So which means after 6 minutes, how many half-life? We have 3 half-life. Jawapan dia 3. So ini 3 half-life, you can count this way, equal to 6 minutes. Okay, first half-life, second half-life, third half-life. Okay, which means 3 half-life involved. Okay, boleh ya? Kalau soalan ini tanya berapakah dia punya half-life. So what is the half-life for this sample? So the half-life is 2 minutes. Okay, the half-life is 2 minutes. So every 2 minutes it becomes 50% from the sample. So after 60 minutes, 50 count per minute remain. Okay, very good. Okay, then kita nak tengok soalan yang ke-6. Okay, question 6. We have a sample of radioactive substance contain 50 gram of the active substance. Okay, this is the ini yang awal ke yang tinggal? Is this the initial or the remaining? You have to check. You have to read the question carefully. If its half-life is 10 days, so given the half-life is 10, dia punya separuh hayat adalah 10 hari. So the question is, what was the mass of the active substance in this sample 20 days ago? Soalan dia. So ini quite tricky ya, Cikgu Yani dia tanya satu sampel radioaktif mengandungi 50 gram unsur radio. So ini yang terkini lah yang sekarang. Okay. Maknanya ini adalah N, this is N. Jika separuh hayat 10 hari, so berapakah jisim unsur sampel 20 hari yang lepas? Macam mana nak kira ini? Okay, how to find this? So first and foremost, you have to check what is the given information, students. So you can list out the half-life is 10 days. Dia punya separuh hayat 10 hari. Ini bilangan sampel yang sekarang, 50 gram. Okay. And how many half-life involved there? Kita nak tahu berapa half-life. Dia bagi tahu half-life 10 hari kan. Dia nak tanya 10 days, 20 days before. Maknanya involve 2 half-life there. Okay. Involve 2 half-life. So kalau you lukis daripada belakang, sekarang 50. Okay. So kalau you reverse to the back, mean ini 100. Okay. 1 half-life sini. Then another 10 days. Ini 10 days kan dia punya half-life. And then you reverse back 10 days before. This one, arrow dia salah, sorry.
Half from there tu.
Separuh lagi. Okay, this one. Okay, arrow dia terbalik. This one. So we reverse back. Kita pergi. So this one 200. Okay.
100.
10 days. 10 hari. So this is the first half-life. This is the second half-life. That's why here 2 half-life involved. Sekarang boleh kira tak yang ini? So which one is N0? Inilah kita punya N0.
Yes.
Ini kita punya N. Ini tadi kita punya N. Ini another method. Kita guna flow. Cikgu suka guna method ini sebab senang nak faham berbanding dengan this formula. Tapi anda boleh juga guna formula ini. So cikgu padam dulu yang ini So how to apply this formula? This is the formula. Okay, so you just do the substitution. N 50 remaining sample, and this is the number of half-life 2, and we are looking for N. Okay, the number of sample 20 years 20 days before. So answer is 200. Ini pastikan anda tahulah macam mana nak kira. Okay, setengah pelajar dia tak reti guna formula ini. Sebenarnya senang saja.
Betul
Formula
cikgu.
matematik yang biasa saja. Okay.
Yang the first paper tadi lebih senang sebenarnya.
Saya suka guna kaedah yang itu, boleh nampak dengan jelas. Tapi ada pelajar yang suka selesaikan secara matematik macam inilah, so anda boleh guna
By
formula
using
ini.
formula.
The answer is donkey. Yes, very good. Okay, donkey 100. Supposed to be 150. Mana 150 in Fizik? So kalau you lukis semula macam ni lah, awalnya dia 200. Okay. So after 10 days, selepas half-life yang pertama, so it become 100. And then after the next 10 days, it become 50 gram. So ini 20 hari kan. Maknanya sekarang lepas 20 hari dia jadi 50. So 20 hari sebelumnya dia adalah 200. Okay, jelas anak-anak semua? Okay, kita tengoklah yang terakhir sekali Cikgu Yani. We have come to our final learning standard for today. Learning standard 4, to solve problem involving half-life in our daily life. Macam mana nak selesaikan masalah? Ini kita tengok contoh soalan sajalah. Oh, I accidentally tak ada. Okay, it's okay Tivesh, no problem. Okay, are you making a kuih for Deepavali? Are you helping your mother preparing for the Deepavali tomorrow, Tivesh? Masak apa Deepavali? Apa yang special? Mungkin boleh share.
Maruku.
Maruku Maruku. Nak maruku ya. Cikgu Yani pun nak maruku tu. Boleh kirim tak? Satu kirim ke Sarawak, satu lagi kirim ke Penang. Okay, Tivesh. Okay, students, let us check for this problem solving. Okay, the first question number 7. We have iodine 31, dia ada satu iodine 31 sedang mereput. Okay, contain 200 grams. So this is the initial content. Okay, and the half-life is given 8 days. You kena highlight lah semua ni. Dia punya half-life separuh hayat adalah 8 hari. The first question, what is meant by half-life? Biskut. What biscuit is your favorite? Tivesh, suka makan biskut apa? Very good. Yes, time taken for sample of radioactive nuclei to half into its initial value. Kena perbaiki sikit lah ayat kamu itu, okay? Time taken for a sample of radioactive nuclei to decay. You miss one point there. To decay. Decay to half. Okay, decay into half of its initial value, initial mass, initial activity. Don't forget to write the word decay. Masa yang diambil oleh satu sampel radioaktif untuk mereput menjadi separuh. Ini kena tulis mereput menjadi separuh daripada jisim ataupun aktiviti asal. Ini keyword dia. Masa mereput separuh jisim asal. Sampel radioaktif lah kena tulis. Okay, time taken for sample to nuclei to decay to half of its initial number. Very good. Okay, next. Okay, give one reason why iodine 131 undergoes a decay process. So dalam soalan kita tadi ni dia tertinggal sebenarnya ini iodine 131. Iodine 131. Okay, why the iodine 131 undergo decay process? Kenapa iodine 131 itu, kenapa dia mereput? Siapa yang akan mereput ni? Yang mana yang akan mereput? Mestilah dia mereput sebab dia tak stable. So dia mereput untuk dia menjadi lebih stabil. So iodine 131 decay because it is unstable. So it has to decay to become more stable nuclei. Ini jawapan dia. Okay. Nukleus tidak stabil menjadi lebih stabil. Ini tujuan sesuatu nukleus itu mereput. Jadi unstable nucleus become more stable. To become more stable. Very good, Tivesh. Okay, C1 student. Find the mass of iodine 131 after 32 days. Hitung jisim iodine 131 selepas 32 hari. Maksudnya berapa banyak lagi yang belum mereput selepas 32 hari. How much iodine 131 which is not decay yet after 32 days. So you can use the formula I shared to you earlier or you can use the arrow method. Mana satu anda lebih suka, anda boleh pilih lah. Okay, so ini contoh. This is the information given. The half-life 8 days. Okay, 32 days which mean 4 half-life involved there. Ada 4 half-life, dia 4 kali. Pada put 4 kali half-life. Okay, so this is the initial content, 200. So after 32 days, how many left? So we are looking for N. Kita nak cari N. Berapa? So you just substitute this value in this formula. Okay, cuba hitung jawapan dia berapa. Okay, you just substitute. N up here is 4 and not is 200. Okay, key share 12.5. Okay, how about the rest? What do you get? Get home, boleh cuba kira. Chiaying, whoever with us there, boleh cuba kira siapa yang ada bersama-sama dengan kita. So the answer is, cikgu tunjuklah jawapan dia, Cikgu Yani. So jawapan dia yes, correct. 12.5 gram. Senang saja kan? 12.5 gram. Kalau nak buat panah tu macam mana? Macam ni lah. 200 gram. Mula dengan 200 gram. Okay. After 8 days, after the first half-life. Okay, berapa? 100 gram lah. Mesti 50%. Okay, so ini T1. And berapa hari lagi after another 8 days? So become 50 gram. For the third half-life, another 8 days. Berapa lagi yang tinggal? 25. Okay. And then ada satu lagi half-life kan sebab 4. So after another 8 days, so from 25, 12.5% left. So 1 half-life, 2 half-life, 3 half-life, 4 half-life. So the remaining sample which is not decay yet is 12.5 gram. Senang saja. So the first method calculation, second method by this arrow. Okay. So ini salah satulah cara dia yang guna arrow tadi. Macam ini. Ada 4 half-life di sana. Okay, boleh ya? Senang saja. Very good, Kiat Hong. Thank you. Okay, question 8. I think this is the last question for today. Okay, the diagram show a detector which is used to detect gamma radiation emitted by technetium-99 is injected into a patient body to detect blood flow. Ini salah satu kegunaan radioisotop lah. Kita boleh kesan kalau ada darah yang beku dalam badan. Okay. The first question, state the characteristic of gamma radiation. Apakah satu ciri sinaran gamma? Tadi cikgu ada tunjuk dalam jadual kan? Anda tulislah mana-mana satu ciri daripada jadual tersebut. Okay, what is the characteristic for gamma, students? So you can say it is neutral. Gamma has no charge, high energy, high penetrating power, low ionizing power. It is an electromagnetic wave. It is move with the speed of light. Boleh tulis yang mana-mana satu yang anda ingat. Okay. Dia ada charge, tenaga tinggi, kuasa penebusan tinggi, kuasa pengairan rendah, dia gelombang elektromagnet, dia bergerak dengan kelajuan cahaya dan sebagainya lah yang berkaitan dengan gamma. Satu markah. Okay, then this detector already shown a reading before the patient being put into the scanner. Dia tak letak lagi the patient ni, bacaan tu dia sudah ada reading. Okay, the question is state one reason why the detector shows a reading. Kenapa pesakit belum masuk lagi tapi dia sudah detect ada radiation from the surrounding. This is because the radiation comes from the environment. Di sekeliling kita ni ada radiation, sangat banyak radiation come from the cosmic rays, sinaran matahari lah the main sources. Okay, so you can write it is from the background reading ataupun from the background radiation of cosmic rays. Sinar latar belakang, sinar semula jadi, sinar kosmik yang dikeluarkan oleh apa yang ada di sekeliling kita. Okay. Then, okay, ini yang terakhir lah. I think this is the last question. Yeah, due to environment radiation. Yes, true, Tibesh. Okay, environment radiation. Especially, mostly comes from the sun lah, cosmic rays. And from the stone, semua batu-batu kan, mereka ada simpan C4, semuanya ada radiation. Okay, all the soil around us. Okay, then this activity of the technetium-99 decreases 1/8 of its initial activity in 18 hours. Dia bagi tahu aktiviti technetium ini berkurang kepada 1/8 daripada aktiviti asal dalam tempoh 18 jam. So hitung setengah hayat bagi technetium. Okay, here we are finding for the half-life of this technetium. Berapa dia punya half-life? Cuba kira. How to find the half-life for the technetium here? Macam mana? Again, you can do this method. Boleh guna method ini. Okay. This is the first content. Satulah 100%. Okay. After the first half-life, reduce into half. Then the second half-life, reduce into another half. The third half-life, reduce into another half, ikan 1/. So we stop there. Kita berhentilah dekat sana. Sebab dia nak sampai 1/8 saja. Which means ini 100%. Ini 50%. This is 25%. So this one 12.5% left. Okay. So anda boleh hitung the first half-life, second half-life, third half-life. So involve 3 half-life there. Okay, involve 3 half-life. The total time is 18. So how to find the half-life mean? 3 half-life. Total time is 18 hours. So the half-life for this technetium is 6 hours. 6 hours. Very good. Kena tulislah 6 apa? 6 minit ke? 6 hours ke? 6 second ke? Jangan tulis 6 sahaja So this one given in hours. So kita tulislah in hours. Okay. Oh, so I guess that's all Cikgu Yani, itu saja. So 6.1 radioactive ray, 4 standard pembelajaran. Cikgu harap kamu dapat. Okay, very good. Get 6. Nampaknya itu sajalah masa yang kita ada. Sebelum Cikgu serahkan kembali kepada moderator. Thank you everyone for joining me. Cikgu ucapkan sangat-sangat terima kasih dan minta maaf sekiranya ada apa-apa yang tersilap kata ataupun ada kesilapan fakta di mana-mana ke. Kalau ada, Cikgu mohon maaf. Tapi apapun, semoga kelas pada hari ini memberi manfaat kepada semua yang menonton, insya-Allah. Okay, tadi Cikgu serahkan kembali kepada moderator. Cikgu Yani, silakan.
Terima kasih kepada Cikgu Hasnitah atas perkongsian yang sangat padat dengan info yang sangat menarik tadi. Tahniah diucapkan kepada semua yang setia bersama kelas pada kali ini dari awal hingga ke saat ini. Sekarang kita akan tunggu link Okey, link sudah pun diletakkan oleh Cikgu Hasnitah. Link rekod juga, itu adalah link rekod dihantar di ruangan chat. Okey, sebelum Cikgu lupa, kita ada 2 lagi kod rahsia yang terakhir 23. Okey, 23. Okey, sila ambil perhatian. Link tersebut akan tamat pada tempoh setengah jam selepas live ini. Okey, pastikan link CJ juga sudah. Link CJ belum
Okey, sudah.
Dan sudah di-paste ke ruangan chat. Okey. Pastikan anda menggunakan email indidik semasa mengisi borang ataupun email yang Cikgu terangkan tadi Okey, kelas seterusnya untuk subjek fizik adalah pada hari dan waktu yang sama pada minggu hadapan. Tolong sampaikan kepada rakan-rakan kamu semua Sila layari www.akademiyoutuber.com untuk dapatkan info terkini dan jadual kelas tuisyen percuma ini. Jom kongsikan portal Ayu ini kepada rakan-rakan dan guru-guru di seluruh Malaysia. Juga diingatkan semua kelas online percuma ini boleh ditonton semula melalui link yang disediakan di portal Ayu. Okey, semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma, insya-Allah. Kita ada penggolongan ke Cikgu Hasnitah? Tak ada?
Tak adalah, sikit saja kita ucapkanlah terima kasih kepada semua dan selamat bercuti kepada pelajar-pelajar kita Cikgu Yani, dan kita ambil kesempatan nak mengucapkanlah selamat menyambut Dipawali kepada T-Bash dan rakan-rakan yang lain yang adalah. Okay, semoga bergembira bersama keluarga masing-masing. Dan apa yang penting, jaga diri, jaga kesihatan dan semoga berjaya dalam peperiksaan percubaan nanti pelajar-pelajar tingkatan 5. Okay, all the best to you. Alhamdulillah, insyaAllah jumpa lagi dalam kelas yang akan datang.
Okey, yang baik datangnya daripada Allah dan sebarang kekurangan datang daripada kelemahan kami sendiri. Bunga dedap di atas para, anda dusun pasang pelita, anda tersilah tutur bicara, jari disusun, maaf dipintas. Sekian, terima kasih. Jumpa lagi di minggu hadapan. Assalamualaikum, bye.
Berita baik untuk semua. Kini Akademi Youtuber memperkenalkan sistem mata gancaran kredit Ayu untuk dikumpul. Jom ikuti kelas tuisyen live Ayu untuk mengumpul kredit Ayu dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.akademiyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi Youtuber.